Well, greetings. I'm in Bodega Bay, more specifically Bodega Head, looking at some rocks here on the beach. And I came across these rocks. These are erosion-resistant rocks. That's why they make up the Bodega Head. They get beaten by all the waves, but they resist. Now, what is this? This is a granitic rock. It's diorite. But what makes this diorite, specifically here in Bodega Head, so unique is that it didn't originate here. Okay, don't make fun of me, I'm improvising, but do you see the state of California? Okay, good. Now that piece of seagrass there represents the San Andreas Fault, northwest to southeast trending. These three clamshells represent the Sierra Nevada batholith. And that little clamshell right there represents where I'm at, the Bodega Head. Now, how did this unique diorite just end up by itself all the way up there? Well, geologists have studied the Sierra Nevada batholith, and they found something very peculiar. They studied the very south region down here, and it matches up pretty well with the diorite up here at Bodega Head. So the idea is if you rewind time, that's where it originated, near the south end of the Sierra Nevadas, near Tehachapi. So it's emplaced. All this is one unit. San Andreas Fault gets activated, and this little piece gets kidnapped and put onto the Sierra, onto the Pacific Plate. And over time, it's been moving northwest along the San Andreas Fault. In present day, that little piece is all the way up there, Bodega Head. The diorite up at Bodega Head, they think originated down here at the south end of the Sierra Nevadas near Tehachapi, almost 300 miles away. And more evidence that these rocks aren't from here is that they differ greatly from the rocks on the mainland, just to the east, on the other side of the San Andreas Fault. As we mentioned, the rocks here at Bodega Head are diorite, but the mainland rocks, again, on the other side of the San Andreas Fault, are of an oceanic origin from the Franciscan complex. This Bodega Head is the northern tip of a vast geologic province that's known as the Salinian Block, whose core is of the same origins as the core of the Sierra Nevada mountains. So isn't that amazing that the San Andreas Fault kidnapped that diorite and transported it up some 300 miles up the coast? It's got this beautiful blue color. You can tell it's just been pulverized. Ooh, look what we got here. So this right here is a pegmatite. So the original magma, this used to be magma. It cooled very slowly because you can really see the individual minerals there. So this magma cooled and then it fractured. Maybe it was during its transport up here to Bodega Bay, or maybe it fractured while it was still down near Tehachapi. But a different magma with a different consistency, these are way different, right? Different composition. So a different magma, liquid magma, oozed and filled in that crack.
I'll stay out here and drink myself a beer. All night long, I'll sing this song to you.
And when the crystals are that big, a couple centimeters like that, you call that a pegmatite. Ooh, look, we got fault gouge up here with a pegmatite here. Look at that, it's beautiful. Oh, look at these colors. Potassium feldspar. Got a beautiful salmon peachy color. Oh wow, look at that. Oh, we got a fault right there. So this was first, then it cracked. That was second, that continuous line, and then it faulted third. Geology 101 in the field. So hopefully your appreciation for this diorite has increased, knowing how long it's traveled. And you could tell, right? Like, it's been no easy ride for this diorite. You can't go a few inches without coming across a fracture. And in some of these bigger fractures like this one, you got a layer of fault gouge in there. It's a soft, almost flour-like consistency. I can scratch with my fingernail. Those rocks have been scraping by each other for so long, it creates a fault gouge. More evidence that this diorite's been on a long journey. Such a handsome rock. But look at this pegmatite right here. See it cutting through? Look at that. Oh man. Wow. That is beautiful. Look at that. So this would be the edge on that we normally see on a dike. You just see the edge, but the way this is weathered, we can actually see the top side of it. So right there is the top side of a pegmatite. And just look at the size of those crystals. Massive. Beautiful colors. That potassium feldspar is one of my favorites. It's got that peachy color. I just dug out some more. Look at this. Oh, how pretty is that? Oh my goodness.
So keep on running, keep on moving, everything's gonna be alright. So keep on smiling, keep on laughing.
Well, thanks for watching. My appreciation for this diorite here at Bodega Head has greatly increased, and hopefully yours has too.